Hello everyone, I'm Stephen Bilby. I've been in the industry for about 15 years doing a range of hydraulic modelling, hydrology, GIS and software development things, and today I'm going to be telling you about something I've been working on most recently, which is Flood Modeler Damage Calculator. We've got a bit of an agenda for today. So the first one is, why do damage calculations? It's a very good question if you've never used damage calculator before. What is it for? Then the data that you need to get damage calculator to run, a look at damage calculator itself, a sample of some of the new features that you will get in the that you can get in the new version that's out now, and then a bit of question time at the end. So the first one of those, why do damage calculations? What's it for? Well, I'm guessing there's quite a few hydraulic modelers on this call. So you'll be familiar with producing flood model results, which tell you that a town could have a flooding problem. We've got some example data here. There's just one flood probability shown on here to keep things simple, but obviously in reality, you may have lots of different return periods. So with that town having a flood problem, there's all sorts of economic damage that flooding can cause. I suppose the obvious stuff is that buildings can get flooded. That costs money to fix, but there's lots more too. So cars get written off if they're flooded. Evacuation and emergency services cost money, and there's risk to life. People can even get killed by flooding. And the mental health costs of flooding are very significant to the economy as well. If all your stuff is destroyed and you can't live in your house for a few months, and it potentially costs you tens of thousands of pounds, that's very stressful. Damage calculator can help you quantify all these things, so it can tell you how many buildings get flooded, what it costs, and what all the other costs are as well. So it can tell you all of those things, but why would you want to know those things? Well, if you quantify those things, it can help choose a solution to your flooding problem, and it can help economically justify building that solution as well. So, for example, if damage calculator said that a flood defence prevented £100 million worth of damage, but that flood defence, well, if you worked out that flood defence only cost £10 million to build, that's obviously a pretty good investment. Looking at some numbers for that kind of example. So you have your original problem here on the left, and then you have some potential solutions. You might want to try building some defence walls to keep the water out. You might want to try storing flood water upstream of the town. Getting into more complicated details, you might want to try different sizes of those things. You might want to try them in different combinations. That could give you a lot of options to choose from, a lot of different damage types that we just looked at to calculate for potentially thousands of buildings and for lots of different flood event sizes as well. So that is a lot of data you've got there. This is where damage calculator comes in, by reducing all of that complexity down to a single number for each option. We've got some example numbers here, so damages in millions of pounds. So if you don't do anything, for example, you could get £100 million worth of damages. We've got that telling us that there. If you built these particular defence walls, damage calculator could tell you that only has £30 million worth of damage remaining. If you built this flood storage area, damage calculator might tell you that you only had £10 million worth of damages remaining. So these numbers here are the information that damage calculator can give you, the damages. Once you've got those numbers, it's some very basic maths to tell you what the benefits of each option are as well. So the difference between 100 and 30 is 70. So your defence walls give you £70 million worth of benefits. The difference between 100 and 10 is 90. So that flood storage area gives you £90 million worth of benefits. You could then compare that with the various options like walls and the cost. No, sorry. You can compare the benefits with what the various options cost to see which are good value for money. So yeah, very short summary. That's what damage calculator is for. It gives you damages, which you can then use to calculate benefits, and compare them with costs to see which option works best. Okay, next bit now, data for damage calculations. What you need is probably fairly obvious from the images in the last part of the presentation. You need some model results. These could be from Flood Modeler, or you could use results from other software as well if you needed to. We've got a few different flood sizes on here. So yes, you need some model results. The next thing you need to make Damage Calculator run, is a property dataset. You could either make your own dataset based on survey, or if you're using Damage Calculator in England, you could use the National Receptor dataset. You can see an example property dataset on the screen here. It gives a point for every property in the flooded area. And if you get the National Receptor dataset, it gives you information about where the property is, how big it is, whether it's a house or a factory or so on. If you're creating your own dataset, you will need to populate your point layer with that information. There's full instructions on how to do that in the Flood Modeler knowledge base. Then the final thing you need is some depth damage curves. Depth damage curves are quite straightforward. They tell you the damage for a given depth. So for an individual property type here, you can see that if this building is flooded to a depth of 0.5 metre, that gives you about £25,000 worth of damages. You can either make those curves yourself based on research or survey information, or if you're working in England, you can buy the multicoloured manual from the Flood Hazard Research Centre. That's all of the data you need. We will have a quick look at Damage Calculator itself now. If you've downloaded the sample Damage Calculator data from the knowledge base, you can try this example yourself with exactly the same data that we're using now. We will now have a look at Damage Calculator. I'll be playing a short demonstration video of it in case of license dropouts or something like that. Here we go. We'll start off by going into Flood Modeler, which we already have open. Then next, we'll open some example data. We'll open some flood data in the form of some depth grids. And we'll open some property data as a shapefile. You can now see your property points and sample flood data in the Flood Modeler interface. And you can get this data yourself to work through the example if you download the sample data from the knowledge base. You can then open Damage Calculator itself by clicking on Results up here and Damage Calculator. This window opens, which gives you the option to bring the depth grids and property dataset that are open in Flood Modeler into Damage Calculator. We'll press Check All, select the property dataset, and press OK. If you're opening Damage Calculator the first time, it will come up with this screen saying that it needs a set of depth damage curves. If you press OK, a browse window comes up and you can navigate to wherever you saved the example data download from the knowledge base. These depth damage curves come in text file format as a collection of CSV files. You can save these anywhere. For the purposes of this example, they've been saved on the C drive. So we select the depth damage curve dataset and press OK. This example depth damage curve data that comes with Flood Modeler is only a sample to demonstrate the file formats. For a full analysis, you could either create your own detailed dataset to the format specified in the knowledge base, or you could buy a full dataset from the Flood Hazard Research Centre if you're working in England. Okay, Damage Calculator is now open. You can see the property dataset that you chose here and the flood data depth grids that you chose here. If you want to use a different property dataset that you don't have open in Flood Modeler, you can do that by clicking here and navigating to a different one. We won't do that for now. And if you want to use some different model results depth grids that you don't have in Flood Modeler, you can do that by clicking here and selecting the ones you want. We'll choose some of those. So we'll choose these for the future year 2040. It asks you the year. You can tell it that. We'll choose some more for the future year 2070. And tell it that those are for 2070. If you look at the interface now, it's got the grids that you selected in the years that you specified for them. So 2024, 2040, and 2070. The future years can represent different scenarios for climate change, for example, or different flood alleviation schemes that could be constructed in future years, or both. If you're doing an economic appraisal, you'll normally want to calculate present value damages, so we'll click that. And you'll normally have an appraisal period of 100 years, so we'll put that in there. This is only an introductory video, so we're not going into all the theory behind that. That's all available in the knowledge base. There's some settings we'll look at as well. If you click on this tab called Depth Damage Curves, that tells you the choice of depth damage curves that you have based on the depth damage curve dataset that you put in. Because we're only using a sample dataset, we can only choose short, no warning storm curves. If you bought a full set from the Flood Hazard Research Centre, you would get other choices like flood duration and water type. Again, there's more detail on that in the knowledge base. You can see the depth damage curves here. If you click on a property type, it shows you the depth damage curve for that property type with depth on the x-axis and damage on the y-axis. There's also a settings tab, which gives you different options for sensitivity tests, the damage types that you want to calculate, and discount rates. There's more details about these in the knowledge base, and we'll leave them on defaults for now. There's just a few other things you need to do before you run your damage calculation. You'll need to tell it where to save the output files. So we've got a folder created for that. All you have to do is put the output folder that you want in here. Then you need to give the results file set a name. We'll call it example. That gets used as a prefix for all of your output file names. Then finally, it's a good idea to save your damage calculation itself so that it records the property file and depth grids that you used and all the other settings that you chose. For now, we'll use the same file path as the output folder. And we'll also call the file example to match the results files. You can call it something else if you need to. You can see that it's now saved an XML file which has all the data in it in case you want to rerun your calculation later, perhaps with different settings. Then all you have to do is press run and Damage Calculator will run. Prompts you to save any changes you've made to the calculation. You can click yes and Damage Calculator runs. Once it's finished running, you will see that some extra tabs have appeared on the interface. There's an output log tab. This tells you the settings that you used. There is a results per property tab. This tells you flood depths and damages for every property in the dataset that you put in. There's also a summary tab, which gives you totals by damage type and flood event. Damage Calculator also writes the results to CSV files, which are saved in the location that you chose earlier. We'll have a quick look at those. Here they are. The first file gives you all of the detailed information that we saw on the results per property tab. Then you have your XML file. Then there is a group of all PVD files, which give you present value calculation information. There's one file for each damage type. There's an error file, which will tell you if anything has gone wrong with the calculation. There's a log file, which records all the datasets and settings that you used. And there's a summary file, which we'll have a quick look at now. This gives you total damages for each damage type and flood event. If you're making an economic case for investment, the most important number is this one. That is the total damage with capping and write-off applied. Okay, so that was a quick look at Damage Calculator and what it can do. Now on to the next bit of our agenda, which is new features in version 7.1 to get both our new and experienced users interested in this new version. The first one is intangible health damages. It implements this DEFRA report here. Previously, calculating this needed some spreadsheet post-processing on damage calculator results. It's now done automatically. It should save you some lots of time and also make it easier to get funding for your project as well. It's very easy to use. All you have to do is tick this box on the Settings tab. Then when you run Damage Calculator, you will get an extra results file and extra row on your summary outputs. Next new feature is property level protection, or PLP damages. That is PLP, for anyone that hasn't come across it before, is things like floodgates and waterproof air bricks. Got a little picture of a floodgate for your house here. This isn't a completely new function in Damage Calculator, but it has been improved to get it up to speed with all the other calculations that Damage Calculator does. So it now does capping right off and calculates damages for every damage type. And that feature is based on this research paper on the right. Again, it's pretty easy to use. If you want to calculate damages with PLP applied, all you have to do is tick the Calculate Damages with Property Level Protection box. Technically speaking, it adjusts the depth damage curves by a range of depth-dependent factors from that report before doing the AAD and PVD calculations. And if you tick that box, the damages that Damage Calculator outputs make the assumption that PLP is in place. So yeah, that function means you can calculate PLP damages and therefore benefits just by ticking a box, which takes a couple of seconds, rather than having to generate a whole new set of depth damage curves, which could take a little while. The next new feature is a simple flood cell function. When you're analysing results, you'll quite often have different flood cells that you want summaries for. You could easily have 3 of these, like in the picture. You could easily have a lot more. If you wanted separate totals, previously you would have had to run Damage Calculator several times, one for each cell, or do some post-processing. That could start turning into a lot of time in data management. So we've added a nice little function where you make a column in the property dataset with your flood cell names in it, and it produces a separate output total summary for each. You can see an example of that on the right here. It's not exactly a rocket science new feature in terms of complexity, but it's definitely one of those nice little things that can make your life a lot easier. Property write-offs. If people have got any previous experience of economic assessment, you'll probably be familiar with doing that, possibly in the context of doing spreadsheet post-processing to get it calculated. There are 2 parts to write-off. The first one is that, well, once a property is flooded at a lower return period than the user specifies, all the damages at that property stop at that point in time, and the discounted market value in the year of write-off is added to the damages. Damage Calculator now does both of those things automatically. It also does that in conjunction with the pre-existing capping function, as you can see on these graphs. We don't need to look at those graphs in a huge amount of detail. All the user needs to know on a day-to-day basis is that Damage Calculator now does all the maths for you, and it no longer requires any post-processing at all to get write-off taken into account.